Hello everyone, so today we will be looking at SI base units and homogeneity of equations for physics. So firstly, there's something called the SI base units, which was developed and is followed by most countries around the world, except for the United States mostly. So there are five main SI base units we need to know about in AS physics. So we know mass, length or distance, time, current, and temperature. And all of these have the units as we know kilogram, meters, second, amps, and Kelvin. So these are the SI base units, and these are always used when dealing with equations. So make sure when you're using equation, using the correct SI base unit and not using some other derived form of it, because you'll get an error in the power of 10. So, how do we derive base units? So deriving base units is quite simple. So firstly, we need to find an equation which gives the unit. So what is newtons? Now newton is a measure of force. I know force equals to m times a. But what's the units of m? Mass is kilograms, so it's kg. And then a, what is acceleration? Acceleration is meters per second squared. So the SI base units of newtons is kg meters second minus 2 since it's underneath. Now let's take another example of joule. You can use any equation which provides the correct formula, but I like to use half mv squared since it doesn't have too much. And since half doesn't have any units, we can ignore that. And we know m, mass is kg, and we know velocity is meters per second, but since it's squared, it will be kg meters squared second minus 2. So squares apply to the formula, apply to the units, so will also apply to the SI base units. And we can find pascals, which is a bit more challenging since pressure has a formula force over area, right? But what is force? Force is also a derived unit. So the overall formula would be ma over area, base area, right? So over here. So what do we know of m? M is kg, a is meters per second minus 2, and area, the cross surface area, is what? Meters squared. So it would mean negative 2 power, since it's underneath. So we can cancel this out. So it'd be left with kg meter minus 1 and then second minus 1. Now, let's look at the more challenging part of these equations, which is to check the homogeneity of physical equations. Homogeneity basically means that it's equal on both sides. So the unit on the left hand side of the equation and right hand side of the equations must be equal. So how do we do this? You need to be able to combine the units of either side, and to check if the units on both sides of the equations, you need to see if they're equal, and if they do not equal, you need to adjust it by adding a constant with the required units. So let us try for this question over here. The average kinetic energy of a gas molecule is given by the following equation. So energy, we know the formula of that is kg meters to seconds minus 2, right? So this is half mv squared. And this will equal to, we can ignore this, where T is the absolute unit of Kelvin, right? So we know Kelvin is over here, and there's an unknown value, just take it as x. So we need to find the value of x. We can move k to the other side. It's just like a normal equation in algebra. It would be kg meters squared second minus squared Kelvin minus 1 will equal to x. And which of these equations matches this? So it would be option D. Now let's look at another question. The answer over here we already know would be C, since the time is in seconds minus 2, so it would be that. But let's just check it again by checking this equation. So we know that density is rho g delta h, right? Sorry, density is mass over volume cubed, so that would be kg over meters to the power minus 3. Gravity is just acceleration, so it would be meters per second squared. And then height, which is just the distance, is meters, hence option C. Now, let's look at another question. The frictional force F on a sphere falling through a fluid is given by the formula this. So we already know F. F is mass times acceleration, so it's kg meter per second minus 2, right? That's what it must be equal to. 6 pi are constant, we can ignore that. A is a radius, so that's meters. We don't know what micro is, and v is velocity, so that's meters per second, and then x. We can just take it as x. So kg, meters per second to the power minus 2, equals to meters squared over time equals to x. We can divide meters squared, so we get kg meter minus 1, right? Since meter squared is getting divided, and in seconds, it's minus 2, we'll just add 1 to that, so it'll be s minus 1 will equal to x. Hence option B. So that is everything regarding homogeneity of equations, and I thank you guys for watching. If you have any questions, please leave them in the comment box. Thank you.